In this question, we've got an equation: y is x squared subtract the square root of 4 add the natural logarithm of x. Show that the tangent to the curve at the point where x is 1 has the following equation. Okay, in some ways that's a really nice question because it's a show that we know where we're starting from, we know where we need to get to. So the first thing we're going to need is a pair of coordinates. We've got when x is 1, so I'd always get the easy mark for part A. When x is equal to 1, y would be equal to, well, it would be 1 squared, subtract the square root of 4, add the natural logarithm of 1. Now the natural logarithm of 1 is 0, so this is just square root 4, which is 2, and 1 take away 2 is negative 1, so negative 1. So our coordinates are 1, negative 1. Get yourself the easy mark. Next thing, let's do the differentiation. So y is equal to x squared subtract this thing here, which is 4 plus natural logarithm of x, and write it in index form to the power of a half. So let's differentiate this. Now this is a simple differential here, and this one we're just going to use the chain rule. So remember what the chain rule says, just a reminder: if y is some function of x to the power of n, the chain rule says that the differential of that function of x to the power of n, you bring down the n, you differentiate the original function inside, so f dashed x, and you keep the function f of x, but you reduce it by a power of 1. So we're going to apply that here. So dy by dx is going to be, for this one, 2x, which is easy, and this one, subtract. So we're going to bring down the half, so half here. We're going to differentiate inside the brackets. The differential of 4 is just nothing. The differential of logarithm x is 1 over x. We're going to keep the brackets as it was, and we're going to reduce the power by 1, as follows. Okay? So just tidying this up, maybe dy by dx is therefore 2x subtract 1 over 2x, 4 plus the natural logarithm of x to the negative a half. Now we want the gradient where x is 1, so we're going to substitute x is 1 in here. So dy by dx when x is equal to 1 is equal to 2 times 1, so 2 times 1, take away 1 over 2 times 1, 4 plus the natural logarithm of 1 to the negative a half. So let's work this out. 2 times 1 is 2, and this would be subtract a half. Now, look, natural logarithm of 1, this here is just 0. So 4 to the negative a half is 1 over 4 to the half, which is 1 over 2. So this would be 1 over 2 times 1 over 2. This would be another 1 over 2 here. And that would be 2 take away a quarter. So 2 subtract a quarter, which will be 7 quarters, like that. All right? Now, at this point, I just do a quick double check. The calculator can help you out. If you give the calculator the original function, it can differentiate it and put x as 1 and see if we also get the answer 7 quarters. So I'm going to say, let's differentiate the original function, x squared, take away the square root of 4 plus natural logarithm of x. I'm going to substitute in x is 1, and I get 1.75. And 7 divided by 4 is 1.75. Watch, 7 divided by 4 is 1.75. So I know I've done this right and I've checked on my calculator. Now we're ready to use the y subtract y1 is mx subtract x1 straight line formula. So what have we got? We've got y subtract, I think that was negative 1, is 7 quarters, x subtract 1. Okay, so that's y add 1 is 7 quarters, x take away 1. And let's just tie this up, multiply everything by 4. So 4y add 4, and multiply out the 7 into the brackets is equal to 7x subtract 7. Let's look up what form they wanted it. They wanted the 7x positive. So 0 is equal to 7x subtract 4y, taking the 4y off both sides, and then take 4 off both sides to get negative 11. And actually they wanted the 11 on the other side, so 11 is equal to 7x subtract 4y, and we're done. So we've done the first part for 5 marks. Then it says the curve has a stationary point with x coordinate x is alpha. They've given it a name. Show that alpha is between 0.3 and 0.4. What we're going to try and solve here, the equation we're trying to solve, you must get this right. We're not solving this if this is a function of x is equal to 0, f of x is equal to 0. We're solving f dashed x is equal to 0. So what we're trying to solve, if I called my original function f of x, I might call it f of x because it's easier, x squared subtract the square root of 4 plus the logarithm of x. What we're trying to solve here is f dashed x is equal to 0. Now we've luckily worked out f dashed x before. It was this thing here. So it was 2x, so we're trying to solve 2x, subtract 1 over 2x. Where do we have it up here? Subtract 1 over 2x, 4 plus natural logarithm of x to the negative half. 4 plus the natural logarithm of x to the negative half equals 0. We're trying to solve that. So this is our function here. This is our f dashed x function. And what we're going to do is we're going to work out f dashed of the two values we're given, namely 0.3 and 0.4, and show that there's a change of sign. Therefore, f dash has a root between the two, i.e. alpha, the stationary point, is in between these two values. So we're going to get the calculator out. I'm going to type in 2x, subtract fraction 1 over 2x, and then we've got 4, so open bracket, 4 add natural logarithm of x, close the bracket of the natural logarithm of x, close the bracket of the 4 plus natural logarithm of x, to the power of negative half, like that. And we're going to calculate. We're going to put in x is 0.3, and we get ourselves negative 0.396, so negative 0.396. And we're going to put in 7.3, let's put 7 there so the round is not wrong. And then we're going to put in 0.4. Hopefully we've got a change of sign. We do 0.0088. So 0.088, like that. And therefore, change of sign between 0.3 and 0.4, and f dash is continuous, so alpha lies between 0.3 and 0.4, as we've been required to show. Okay, and then it goes up here to say, so I'm going to take a photograph of this here just to stop me scrolling up. So taking a photograph there and scrolling down, it asks us to show the following. It says, show that alpha is a solution of that equation there. Now, we already were talking about our equation. This is the equation we're trying to solve, so this one here. So let's rewrite that. We're trying to solve 2x, subtract 1 over 2x, 4 add the natural logarithm of x to the negative half is equal to 0. Now we're trying to rearrange it so it looks something like this. Now looking at this, I look at it and I think, well, I'm trying to get to this point here. So this is where I'm trying to get to. Here. I'm starting off at here. How am I going to do that? Well, look, I've got 4 plus natural logarithm of x there, and I've got this in my original. So I've got to preserve that no matter what. And then it seems like I've got an x equals, so x is the subject of the formula. So I'm thinking somehow combine these x's and make this x the subject of this formula, and it will look like that. So that's the process I'm going through when I think that. Now the only thing I can do at this point is multiply everything by a 2x. So I would get 4x squared, subtract 4 plus the natural logarithm of x to the negative half is 0. I could add this to both sides, so I would get that 4x squared is 4 plus the natural logarithm of x to the negative half. And then I could divide both sides by 4. So I could say that x squared is a quarter. 4 plus the natural logarithm of x to the negative half. And then I could square root both sides. So x, usually I get a positive and negative, but I'm obviously just taking the positive answer here. If I square root a quarter, I get a half. And if I square root this, I'm basically raising it to the power of a half. I would get 4 plus natural logarithm of x to the negative a quarter. Because a half multiplied, so because negative half multiplied by half is negative a quarter. Okay, so that was the process of taking square roots of both sides, and I have shown that alpha is a solution of that by rearranging. Now I'm asked to use this as an iterative formula. So what I'm asked to do is I'm asked to use xn plus 1 this is part D, is equal to a half 4 plus natural logarithm of xn, all to the power of negative a quarter, where x0 is 0.35. And I'm asked to do that, to find x1, x2, x3, x4, and give my answers to 5 decimal places. So this is actually very straightforward. Calculator out. First thing, put your x0 in. 0.35 equals. It's stored under the answer function. Then type your iterative formula. So you've got a half, like that, and then open brackets. 4, add the natural logarithm of not x, but answer. Close that logarithm and then close the whole bracket there, to the power of a negative a half. So a quarter even. So there we go. All I've got to do, press equals. So to 5 decimal places, 0.385181. So x1 is 0.385151. 38151. Press equals again. 0.37877. x2 is 0.37877. Again, x3 is 0.37899. Now I'm going to have to write this. One down. Over here, let me write x3 down as rough working. 0.378, 0.3789994. So if I was to round this to 5 decimal places, 1, 2, 3, 4, 5 here, this would now become, I'd round that up to a 10, so I'd put the 0 there and carry a 1. That would become a 10, so put a 0 there and carry a 1, and that would now be a 9, a 7, and a 3, like that. So x3 to 5 decimal places is 0.37900. x4, how far did they want us to go to? They just wanted x4 as well. So x4, press equals one more time, and I get the following. So x4 is 0.37898. So x4 is 0.37890. So 1, 2, 3, 4, 5 decimal places, it would stay as that. So it'd be 0.37898, like that. And that is x4 to 5 decimal places, and we're done.